Hello everyone, let us see next example. The question is find analytical function f of z is equal to u r theta I v r theta. The bracket means u is a function of r theta. That means fz is given in the form of polar form, okay, where f of z is equal to u plus iv. U and v are both in the polar form r and theta. That means we have to use CR equations in polar form. Okay, now we have to find out this analytic function f of z such that v is given by this. V is given, we have to find out f of z. That means we have to find u. Okay, one function is given, other function we have to find out using CR equation, because fz is analytical function here, and this is given in the polar form. That is the only difference. Okay, procedure is same, which we have applied to the Cartesian form. Polar form procedure is also same, but the CR equations are different, and integrations are with respect to r and theta. Variables are different only. That is only difference. Okay, let us start. Above fz is in polar form, that is f of z is analytic and f of z is analytic. Then CR equation by CR equation are given by w by w r is equal to 1 by r w v by w theta. First CR equation. Second, w by w theta is equal to minus r w v by w r. Okay, now first v is given, we have to find out u from these two equations. First, write down v given r square cos 2 theta minus r cos theta plus 2. Now we have to differentiate v, because we have these two equations. We want u on LHS side. On RHS side, v is present, and with respect to derivatives are present of with respect to theta and r. From any equation we can start. Let us differentiate equation, this above equation v with respect to r. Okay, then for w v by w r becomes at that time with respect to r, theta becomes constant. With respect to theta, in the derivative r becomes constant, because it is partial derivative. Okay, now w v by w r means derivative of v with respect to r we have to take. R is present in these two terms. 2 is a constant, derivative is 0. Now here cos 2 theta is constant, that's why cos 2 theta is again constant. To keep that as it is, and r square derivative is 2r. Minus again cos 2 theta is constant, r derivative with respect to r is 1. Okay, now again differentiate this v simultaneously with respect to theta. You can do this step after some steps also, because we are not going to use this immediately, but you can write it as in this step only you can write down. Now differentiate above v with respect to now theta. Okay, what we get? Differentiate v with respect to theta. W v by w theta is equal to, now theta is the variable, r is a constant, r square keep as it is. Now cos 2 theta derivative is minus sin 2 theta into 2, multiply that 2 before this r square. Okay, because it is constant. Now minus as it is, r with respect to theta we have to differentiate. R is constant as it is, and cos theta derivative is minus sign, minus sign becomes plus. Okay, 2 derivative is 0. Okay, now these two derivative we have just calculated. Now you can use these two equation. Okay, first, now equation number 1, see, this is w v by w r is here in this equation. That's why w v by w r is nothing but minus 1 upon r minus r, take on that side, w by w theta. That's why from 1, equation number 1, w v by w r is nothing but minus 1 upon r w by w theta is equal to w v by w r is this 2r cos 2 theta minus cos theta. Okay, now take minus r on that side, we get w by w theta becomes minus 2r square cos 2 theta minus plus r cos theta. Okay, now this we get w by w theta. Now we want u, that's why we have to again integrate this equation with respect to theta. Okay, that's why integrating both sides with respect to theta. Remember, theta is not only variable present here, r is also variable. That's why we have to take integration constant as function of r, not c. Remember that. Okay, because two variables are there. Now integrate above equation with respect to theta. Integration derivative gets cancelled. U is equal to minus, with respect to theta we are going to integrate, that's why minus 2r square is a constant. Take it out from integration. Cos 2 theta integration is sin 2 theta divided by 2 theta derivative should be divided, that is 2. Okay, plus r is a constant with respect to theta, that's why cos theta integration is sin theta, plus integration constant is function of opposite variable of theta, that is r. Okay, that is phi of r. Suppose this is phi of r. In earlier example we take phi of x. Okay, like that we have to take the integration constant as phi of opposite of theta or other variable which is present with theta is r, that's why it is phi of r. Okay, now this is our answer. We have to find out u, that's why this is our answer, but in this answer we have to find out phi of r. This is our extra job here. That's why now simplify this. 2 gets cancelled, minus r square sin 2 theta plus r sin theta plus phi of r, call that star. Okay, now we have used these two CR equations. Among that we use this equation. Okay, here now we have to use this equation, because in this equation u is also there, that is we are going to find, and above u by above theta is already there. This also we are not still used anywhere. Now this is the equation, and this is the equation, second equation we are going to use now. Okay, now differentiate. For in this equation u derivative is present with respect to r, that's why differentiate this u with respect to r. Theta is constant. What we get? Dava u by dava r is equal to, with respect to r theta is constant, sin 2 theta as it is. Okay, and r square derivative is 2r, plus r derivative is 1, sin theta is constant as it is, and phi of r derivative with respect to r is phi dash of r. Okay, now we have 1 dava u by dava r here. Now again from this equation number 1, dava u by dava r is 1 by r dava u by dava theta is here. Therefore from using equation 1 and 2 we are going to write one more equation. Okay, now from equation 2 and equation this, what we get here from 1 and 2, or okay, see, this is our last step, dava u by dava r, and dava u by dava r from this equation is 1 by r dava u by dava theta. Put this value here in LHS side. What we get from equation number 2, we get LHS side 1 by r dava v by dava theta, and RHS side is 1 by r okay, it is 1 by r dava v by dava theta here. Now we are going to split these steps here. We'll call that equation number 3, and now from here we have to find this. That's why multiply this equation by 1 by r. What we get? This from equation number 2, that is 2. 1 by r dava v by dava theta. 1 by r multiply both sides by 1 by r dava v by dava theta becomes 1 by r into this term as it is. Okay. Now r gets cancelled, 1r gets cancelled from this. We get minus 2r sin 2 theta plus sin theta. This we get 1 by r dava v by dava theta from this equation. Okay. Now 1 by r dava v by dava theta is dava u by dava r from equation number 1. That's why from equation number 1 and equation number this 3 we get, or comparing, this is, you can write down this dava u by dava r from CR equation 1. Okay, here this step, this is equal to this by using CR equation this. Now okay, Now w by dava r is this, okay, and we have one more w by dava r is this, okay. Here w by dava r is this. Now from earlier example, w by dava r is this. Comparing these two, LHS side is same, that's why RHS side must be same. Okay, minus 2r sine 2 theta is same here, and sine theta is also same, that's why phi dash r must be, if these two equations or RHS side of the equations have to be same, then phi dash r must be equal to 0. Okay, then and then only these two becomes equal. That's why from this equation, comparing from above equation, we get phi dash of r is equal to 0. Now our aim is to find out phi of r. Therefore, to cancel out this derivative effect, we have to take integration on both sides. Now therefore, integrating with respect to, obviously there is only one variable r is there, that's why it is normal integration. That's why taking integration on both sides, we get derivative integration gets cancelled. Phi of r becomes 0, integration is 0, you don't need to write 0, and plus integration constant, now constant c, say c, because there is only one variable, that's why normal integration we consider constant as c. Okay, this is now number constant. Okay, now put this value phi of r is equal to c in our answer. What is our answer? U is our answer, this star. That's why put this value phi of r from that equation. In this equation we get u is equal to minus r square sine 2 theta plus r sine theta plus phi of r is c. This is our answer for u, and our original question is to find out analytical function f of z, and out of that v is given. We are just found u, calculate u. That's why putting together u and v, our answer for analytical function f of z becomes f of z is equal to u plus iv. F of z, put u value here, plus I into v is already given. Okay, just go on practicing these equations, these examples. Okay, same examples you take and try to solve it blindly. Okay, until and unless you solve it blindly or without watching in your notebook, you have to go on practicing that. Okay, but these are very easy examples, only derivatives and simple integrations are there. Just you have to use CR equations and the theory of analytical function, and questions are straightforward. Okay, let us see now next example. If f of z is a regular function means analytical function, regular function, holomorphic function, these three are equal or synonyms. If z is analytical function of z, then prove that this we have to prove. That means we have to solve LHS side, then we have to show that this is equal to RHS side. Okay, let us start. Let f of z is equal to u plus iv. Mod of f of z is equal to under root of u square plus v square. Mod of this function is nothing but under root of real number square plus imaginary part square here. Okay, now here mod of f z square is there, that's why its square becomes square, and square root will cancel, u square plus v square. For our convenience, because what is LHS side? If you take this term inside, we have to take derivative of this term with respect to x and with respect to y 2 times. That's why for our convenience, call it as phi. Okay, now let phi is equal to, therefore u square plus v square. Now differentiate this phi with respect to first x. Differentiate with respect to x. This phi we get u square derivative is 2u into w by w x should be multiplied because it is chain rule, plus v square derivative is 2v into v derivative should be multiplied with respect to x, that is w by w x. This is chain rule of derivative. Now again we have to differentiate this equation because it is double derivative with respect to x again. Okay, now differentiate this equation above double derivative, that is with respect to x again. We get w phi by w x, double derivative is w square by w square phi by w x square. Now see, this is 2 is a constant, take outside. Okay, now you have to take derivative of this plus derivative of this with respect to x. Now u is a function of x and y, already we know, and w by w x, derivative of u is also a function of x and y. That's why we have to use product rule here. derivative multiplication rule. Okay, now see, u into derivative of w by dx with respect to x again is double derivative. Okay, plus v into, that is w by dx into u derivative with respect to x is w by dx. This is u into v rule. Bracket complete, plus this again to take outside because it is constant. Again u into v rule here. V into w by dx derivative is w square v by dx square, plus v as it is w u into v rule, that is w by dx as it is into derivative of v is w by dx. Okay, this is the only main step of this example. Okay, now simplify this. What we get, w square v by dx becomes, okay, see, w by dx into w by dx become w by dx bracket square. Here also w by dx by dx become w by dx bracket square, and this 2u w square u by dx square plus 2v w square u v by dx square as it is. Okay, now this way, first derivative we have obtained, derivative of this, that is phi with respect to x. Now similarly derivative of this with respect to y, double derivative of this with respect to y also we have to find. But if phi is symmetric function, because u and v are functions are same here. U square is there, v square is there. Format of the u and v function is same. That's why similarly we can write down the absurd derivative of phi with respect to y using earlier derivative this. Okay, if you want w square phi by w y square, what will be the difference here? What difference we can make, or we can suggest? Only replace x by y everywhere. That's it. Rest of the terms as it is. Understand? Therefore, similarly, second derivative of phi with respect to y is this. Now, what is our main question? We have to add these two derivatives. Okay, that's why adding above two equations, we get addition of these two becomes now. These two terms first, okay, as it is here, plus 2u is common here, and addition of these two. Take 2u common outside and addition of these two here, plus 2 is common and take these two terms, or write down this 2v is common here and take this two term addition here, and rest of the terms write down as it is. Okay, addition of all these terms. Now given fz is analytical function, that's why regular function means analytic function, that's why it must satisfy CR equations. Now by CR equations, above equation, and one more a note we have to recall, that fz, if fz is equal to u plus iv is analytical function, then it must satisfy CR equation. And if fz is equal to u plus iv is regular or analytic function, then u and v must be satisfy the harmonic equation, that is Laplace equation. They must satisfy Laplace equation. What do you mean by Laplace equation? Already we have, this is the first equation of okay, where is the Laplace equation? See here. Any solution of the Laplace equation is called harmonic function phi. This is the Laplace equation. That means if u fz is an analytic function, that is u plus iv, then u and v must satisfy the harmonic function equation, that is the Laplace equation. Instead of phi, you have to replace u and v, and addition of this two derivatives must be equal to 0 is the Laplace equation, and u and v satisfied this Laplace equation because they are harmonic function if fz is an analytic function. That is the theoretical part. Okay, now we are going to use that theory here. Therefore here by CR equations and also by Laplace equation. What is TR equation? These two are CR equation in Cartesian form. W by W x is equal to W of v by W y. W by W y is equal to minus W of v by W x. These two we are going to use here. And here W square u by W x square plus W square u by W y square must be equal to 0 because u is a harmonic function. So and again v is also harmonic function. W square v by W x square plus W square v by W y square must be equal to 0. Okay, put these values in above equation. Now this is here, this is the same, that's why this is 0, and this is same, that's why it is also 0, where we have only these 4 terms. Therefore we get above equation becomes LHS side same is equal to 2 times W by W x bracket square, 2 times, now replace W by W y by minus W v by W x here. Okay, plus this is 0, this is 0, no need to write to 0, plus 2 times again W by W x W v, okay, W v by W x as it is bracket square plus 2 times instead of W v by W y put W by W x here. Okay, and only 2 terms we are going to replace because these 2 terms are equal to these 2 terms, that's why. Okay, now simplify this. Minus square is plus square, that's why from each term 4 is constant because, or take see this term and this term same, 2 times this plus 2 times this same term becomes 4 times W by W x square, plus this also minus square is plus, that's why these two are same, 2 times plus 2 times becomes 4 times W by W x bracket square. Take 4 constant outside, W x by W x square plus W by W x bracket square, that is ux square in our notation plus vx square. Okay, now we have this this is our LHS side. Okay, now what is our RHS side? What we have to prove? It must be equal to 4 times mod of f dash z bracket square. Now we have to recall this. Fz is u plus iv, therefore f dash z is ux plus ivx. Okay, therefore mod of f dash z is under root of ux square plus vx square. Now taking square on both sides, we get mod of f dash z bracket square becomes square root get cancel ux square plus vx square. This is this term. That's why answer for this is 4 times this is mod of f dash z bracket square. This is the RHS side. Hence proof. Okay. Now let us see next example. Find analytical function f of z. We have to find f of z where u is given. That means ultimately we have to find v, other function v, and at the last combine these two we get f of z, and this is an analytical function, that's why it must satisfy CR equations. In x and y means these are Cartesian form. Okay, let us start. U is equal to this, we have already studied, but one difference is there. Okay, add one more here. This find f of z in terms of z. Add one more example itself. Okay, add this is the other method. Okay, write down. Let u is equal to, this is a given term, e raised to x cos y minus y sin y plus 2 sin x. Now take e raised to x inside because we are going to use CR equation, that means we are going to calculate derivatives, that's why to make this function simpler, take this e raised to x inside, we get x e raised to x cos y minus y e raised to x sin y plus 2 sin x. Okay, now take derivative of u with respect to both x and y. First w by w x, here x is there, here x is there, cos y is a constant, take outside, you have to use product rule here, u into derivative of v plus v into derivative of x is 1. minus y sin y is a constant with respect to x, e raised to x derivative is e raised to x, plus 2 sin derivative is cos x. Okay, this is derivative of u with respect to x. Now take cos y inside, x e raised to x cos y plus e raised to x cos y minus y e raised to x sin y plus 2 cos x is the derivative of u with respect to x. Similarly, we have to find out derivative of u with respect to y. Differentiate this with respect to y. What we get here, y is there. This is constant with respect to y. X is constant. That's why x e raised to x as it is. Cos y derivative is minus sin y. Minus here e raised to x is constant. Take outside. Y into sin y. We have to use product rule. U into derivative of sin is cos plus v into derivative of y is 1. U into v rule plus 2 sin x, it doesn't contain y, that's why derivative is 0 because it is constant with respect to y. Okay, now take this e raised to x inside. What we get, this is equal to this term as it is minus y e raised to x cos y minus plus minus e raised to x sin y. Okay, now next step is same CR equation. Dou by dou x is equal to dou v by dou y, and dou by dou y is equal to minus dou v by dou x. Therefore, this dou v by dou y dou v by dou x becomes minus dou by, from this dou by dou y, and this we have already calculated here. Take minus, multiply with this, becomes plus. We get this term as it is here. Okay, now we want v. Okay, see, if such function is there where find analytic, in earlier example also you can do that. This is other method to find out. See, one question is there, if u is given, find out v, then you have to follow the earlier examples method. Okay, you have to use CR equations, take integration, then again take derivative and so on. But here in this example, or in earlier example also, the question is simply find f of z. They have not asked to find separately v. That's why we can use very simple another method here we are going to use, that is called Milne-Thomson method. By using that method, without solving or without finding v, we can directly get f of z in terms of z. Okay, you can use this method everywhere whenever they have asked directly for f of z. Okay, if u is given and their question is find v, then you have to follow the earlier examples method. Okay, now here they have not asked to find v directly, they have asked what is the question, they want f of z. That's why we are going to use another very simple method, that is called Milne-Thomson method. We are going to introduce here. Let us see. Okay, until this it's same. Okay, now let f of z is equal to u plus iv. Therefore f dash z is equal to ux plus ivx. This is our assumption. We know, you have to mug up this. Now ux is this, okay, and vx is this. That's why we use CR equation here. Vx, we don't know v. That's why how to calculate Vx, by using CR equation here. This is minus comes on that side, dou by dou y we know here. That's why it becomes Vx is this. Now put this value of ux and Vx here as it is. Okay, now this is f dash of z. Now by Milne-Thomson method, we have to put x is equal to z and y is equal to 0 in above equation directly. Okay, what is the Milne-Thomson method? Put x is equal to z everywhere and put y is equal to 0 everywhere. This is very simple method. That's why what we get, f dash of z is equal to, everywhere x becomes z, y becomes 0. That's why sin 0 is 0, this term becomes 0. Cos 0 is 1. Here here cos 0 is 1. This becomes e raised to x is z. Here z into e raised to z. Cos 0 is 1. E raised to z. Cos 0 is 1. Sin 0 is 0. Again plus 2 cos x value is z plus I into, here sin y is 0. Sin 0 is 0. Here also sin 0 is 0. And here y is there and we have to put y is equal to 0. That's why this total term becomes 0. Okay, that's why f dash of z becomes, final answer, z into e raised to z plus e raised to z plus 2 cos z. this we get f dash of z. What is our question? To find f of z. That's why to cancel out the derivative, take integration both sides with respect to obviously only one variable is there, z. We get integrating both sides, we get derivative integration gets cancelled. F of z is equal to integration of z into e raised to z dz plus e raised to z integration is e raised to z plus 2 as it is, cos z integration is sin z, plus now integration constant we have to take c because only one variable is there, that's why it is c. Now this is u into v rule, again u into e raised to z integration is e raised to z, second term minus z derivative is 1, e raised to z integration is e raised to z. Okay, this is bipart rule in general. Integration of u into v is u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus and so on until we get 0. We have to do this procedure where u is first term, v is second term, by Liet rule obviously. This is z is arithmetic, e raised to z is exponential, that's why it is u into v rule. Okay, u suffixes are the integration, dash means derivative. Okay, u into v1 means z into e raised to z integration is e raised to z, second term minus u dash derivative of u is z derivative is 1 and e raised to z integration is e raised to z, second term plus u double dash means here 1 derivative is 0, that's why this process ends here, that's why this is the bipart rule here, plus the rest of the terms as it is. That's why final answer is f of z is equal to z e raised to z. This 2 becomes cancel, same term opposite in side to opposite in sign, to sin z as it is plus c. Okay, this is our answer. This is a very simple method, you can use it wherever fz they have asked for. You have calculate fz in terms of z or simply fz. This is one more example for you. Homework is there. Find analytical function f of z u plus iv where u is given and you have to find out v. You have to find out fz. Use the earlier method, Milne-Thomson method, and calculate f of z. Answer is this. Okay.